Hello folks. So in this video, I'm going to actually try out some experiments. I'll start with this experiment of exhausting the RAM in Linux. So I'll just say in Linux for now. So using a C program. So I'm just going to look at just a minute. So close this up. I'll look at how to use new in C language, C programming language, right? So plain C using new. So new operator is a feature of C++, not C. Okay. So in C dynamic memory, okay. So you can't use new. Instead, you can do malloc, memory allocation, I guess. I don't know what is calloc. Handle using the standard library functions malloc, calloc, realloc, and free. Okay. So there's no new and delete. Instead, it's this. So pointer name equal to cast type, malloc, size and bytes. Okay. So allocate memory for one integer, right? So size of, okay, looks like you can say size of and provide this. So calloc is similar to malloc, but it takes two arguments, number of elements and size of each element. Okay. And initializes all allocated types, bytes to 0. So pointer name, cast type, calloc, number of elements, element size in bytes. Okay. So there is no example for this calloc. What about realloc? Okay, I want to check that out later. Deallocate that was dynamically allocated by malloc. Failing to deallocate memory leads to memory leaks. Okay. Does this function ever fail? I'm not sure. So okay. So yeah, I mean later I'll say C++ also and try out malloc in C. Try out calloc in C and try out realloc in C. Then try out free in C. Then we'll finally try out I think new in C++ and delete. I think is the thing. So cool. So how do you use new and delete in C++? Let me see. So you just say new, allocating an array of objects. New int of 10. Okay. So integer pointer array. So okay, so this is allocate memory for an integer of 50 for an array of 50 integers. Okay, this one is 10 custom class objects and delete is just delete, right? So it's not, yeah, it's just delete. We'll come back to this later. For now, I'll just do this how to use malloc in C. Okay, so we need to include this and then allocate memory for 5 integers. Check for allocation failure. Okay, so this is size allocate memory for 5. This is not 5 integers, this is 5 pointers to integers. Okay. hmm. Check for the returns null if the memory allocation fails, if there is insufficient memory available. It is best practice to always check the return pointer before using it. Okay, cool. So let's just try this out. I'll write a C program here. Malloc. Wait, I'll just say exhaust. Or actually, I'll start with malloc. Let's see. Malloc example, right? And I'll say hash include cd. This is lib dot h, right? And So I have some C programs here. Should be int main void, and okay. I think I can simply say int main. Do I need void? Okay, it takes an integer. Okay. And so use the allocated memory. So it says of I is equal to I into 10. Access like an array. Okay, free the memory. So this has to be ideally a pointer. Oh, so it's actually dereference the pointer, so it's not PTR, but instead star PTR, so integer, size of integer. So anyway, so I'm just gonna go ahead and just say int uh, PTR, and PTR is equal to, so in PTR star PTR you have to put semicolon. If you don't, I think it's a problem. So you say malloc, right? Malloc, and you say how many bytes. So you just say, let's say one size of, and then int, right? Now this one says expected thing. So here, yeah, cool. Now let's run this. I'll also use sleep over here for 100 seconds, and I'll just say return 0. Return, that's all, not return 0. Expected, okay, return 0. Over here, do you need anything else? So we also need to check if pointer equal to null. Okay, PTR, no, I don't know what's showing up there, but anyways, this is the thing that we need. Is equal to null. Then you have to printf this and exit state. So I'll just say this. Right. Now let me try to run this. Right. So I'll go to nuts. I'll run this in my macOS first, and then we'll try this out in you know. By the way, GCC. I want to see if you can just say input hyphen I. Run GCC. So I'm looking for hyphen I. Let's see, hyphen V hyphen C and D E F G H E F. Okay, think hyphen I should be here in the map. H, yeah, hyphen. Interesting. Hyphen I is not shown here. I wonder why. Anyways, I think then you just need to say commands. Forgot what did I put? Commands for bomb. Commands zombie process. It was GCC. Okay, I didn't have hyphen I, only hyphen O. So GCC hyphen L. Did it have hyphen O? Yes. So it's not, there's no long format of this hyphen O, that's all. So GCC and malloc experiments, malloc. So it says printf do not support implicit function declarations. Include the header stdio or explicitly provide a declaration for printf. Okay. Okay. So apparently, if I put this, will it work? Let me just simply try that out. Implicit function declaration. No. Cool. I will just go ahead and just, okay, wait a minute. Example.log. So I'll just make it as mlog. Okay, cool. So here I'll just put hash include stdio.h. Cool. This is required in this. If I remove this, let me just see how that works. Call to undeclared library function. Include the header stdio library or explicitly declare. Right. Cool. This is also exit failure is also not there, so let's use that. Cool. So now if I run this, okay, I think sleep basically we've used it. Oops. Let me get that going. Okay. So sleep we had used it in here. Zombie processes sleep. So I think sleep is in wait. It's uni does it include? It's probably in uni std down. Okay. Let's see if that works out. Yep, that's the one. So when you just do mlog here, ideally this should just wait and it should have allocated. So if I do top, I want to see only for one command. Man top to be able to see that this much RAM has been allocated. PID process ID. Okay, hyphen PID and this PS. So I think hyphen PID. I'll just do that. Top hyphen PID. This. So it uses some 976 KB of memory, right? Let me stop that and it should be gone, right? Let me put this in a loop and just simply try out things. Sleep 100 and let's put this test in. So let me just say for int I equal to 0, I is less than 10, I plus plus, and okay, cool. Here it is. Okay, so neatly formatted and cool. So now let me actually run this. Um, so this is the thing to run. So here I should see 992. After every 10 seconds, this should change. Interesting. So it's currently in sleeping state. Now it's 100,000. Okay. So basically, when it's sleeping, it clearly says that it's in sleeping state. Interesting. Let me just put this as sleep. No. sleep experiments. What does it mean when top says that a program is sleeping, is in sleeping state? What does it mean? Mean for sleeping, and what's that exactly supposed to mean in terms of CPU usage, etc. Right? So here you should see that this keeps increasing, right? So currently it's sleeping, so we'll wait. So, and in the meanwhile, I'll also see if I can actually do a. Okay, I can't actually put process limit as of now, because in Mac I have to check how to do process limits. But let me just say, what is boosts? Interesting. I wonder if it's done. Should I put probably just 1 second of starts or 2 seconds? And just said memory allocated. I is percentage D, comma I. So it's dead. So I need to check out what is PS here. So this cool. So here it's 10401056. Okay, it doesn't become bigger than that. I think it doesn't show the exact thing over here. What if I actually just allocate 1 byte at a time? Just a minute. Okay. So what if I say instead of size of int, just say 1000 bytes, right? And put this as every 3 seconds or every 4 seconds, right? I want this to be in one line so that I don't miss compiling it, right? I want this to be coming up. So here you say 1000 bytes. 1000 bytes is the thing that's coming up. 1184. Is it? 1216. Okay, so you can actually see 1000 bytes going. So I think that's it. So 1248. That's where you stop. So let me see. Allocate memory for 5 integers. How to use malloc in C. Uh, in free and C. So size. So the size is the number of bytes to allocate. Okay, it is best practice to use the size of operator to ensure the correct number of bytes is requested regardless of the system architecture. So value if it returns a void pointer, so which can be assigned to a pointer of any type, any data type. So if the allocation fails, it will give null. Cool. And then you can give free and for the first byte, and what if you give for the last? I mean, some other between byte. I don't know. But check. So experiments. Uh, experiments for RAM. Try out free in C where the pointer is not pointing to the first byte of the dynamically allocated memory, right? Memory block, right? So something to try out. And yeah, this is in bytes, right? So it was basically 1000 bytes, so 1 kilobyte ideally every time, but then I saw 100 kilobytes increasing every time. So if I do 10,000 bytes, I think this should come up. So this is 1152. Interesting. It doesn't increase much. Okay, 1184. I won't actually just go ahead and put 10 instead of 10,000, 1216. It just increases the same amount of 10, 1248 probably next. Yeah, 16k 32. So it's 32,000 somehow. Let me do 100,000 each time. Let's see how that goes. Right. Let me do that. That's 1072. Okay. It's 58 probably. Not 58. 48. So 48 kb has increased. Next doesn't increase again. Interesting. Okay, 48 increases by 48. Interesting. 1264 is the last one, I think. I'm not sure. Let's see. Nope, nothing much came up. So we need to see how the memory is allocated. Yes. How memory is allocated. And I'm also going to try out PR limit over here now. So process limit gives you a limit on the process. So let's just say 1 minute. So let me just start off Ubuntu container and just a minute. Okay, cool. So here I'm gonna actually run this program. And I'm gonna say actually 1000 bytes is 1 kilobyte, 1000 kilobytes is 1 megabyte. So 1000 bytes, 1 kilobyte. So this is 10 per 6 bytes, so it should be megabyte. So let me go ahead and put that here. malloc example.c and I will run this. So I'll put it as commands here. Or yeah, cool. I'll run this now. Okay. Apt update sudo apt update sudo. Just a minute. Sudo apt install build essential. Sudo apt update install build essential. Right, so now this should work. This is memory allocated to I is 0, I is 1, PS top FNPID. Interesting, this doesn't show up here. PS aux. Interesting. So let me actually stop this here and say grep malloc, right? So top help hyphen PID. So I'll just say, I think it's this one. Interesting. Doesn't show. I think I chose the wrong PID. Let me see. PID is the first one, right? Weird. Why am I not able to see it? If this is the one, I should have been able to see it. And top 27868. Yeah, it's there. Cool. So it says memory percentage, 0% is used. I want to actually not see percentage, but instead I want to see the actual values. M toggle load memory. Okay, memory uses 12 MB over here. Okay, let's run this again. So this is memory is 12 MB. C memory used by process Linux. H top press to sort the process by memory usage. Percentage. I want the actual resident by set by size. The process is currently using. Okay, virtual. Okay, so interesting. So virtual memory says the total used by the process, including spark memory and shared libraries. Interactive. Okay. Okay, so resident set size. Interesting. Let me actually put this as 1, 2, 3. Let's see if that helps. Uh-huh. Let's stop this. Do I have htop? Yes, I do. Full htop help hyphen PID. Okay. Cool. So I'll just do this first. And let's say stop PID this, right? So here you can see virtual it's 2800 3817 MB. This is the virtual memory size. Okay, interesting. This keeps increasing, but so it goes to 9 GB. Though this does not have the 9 GB, by the way. Interesting. Virtual and display. Okay, let's check this out later then. So how to check exact memory used by a process in Linux, and what is residence set size, and virtual memory size, and shared memory size. Okay. How are we able to allocate um, 9 GB plus uh, RAM in a 8 GB? No, not 8 GB. I think it's 4 GB. LSM. I think it's totally 4 GB, right? It's weird that I mean it's showing like this. I mean, gotta see in a 4 GB RAM machine using MLOG in C in a 4 GB machine. Cool. That's all I had for this video. I'll probably try more things in a different video. I'll see you next one. Bye bye.